Now, further experiments indicated that the nucleus itself had little particles in it, smaller particles. It wasn't just a positively charged blob. Here is the nucleus of a helium atom, and it also happens to be an alpha particle. It contains 4 particles. There are 2 of them here that have a positive charge, and those are called protons. They have a +1 charge relative to electrons, which have a -1 charge. They have an equal and opposite charge. And they have a mass, which we're going to express in atomic mass units. And we're going to say a proton, or one of these other particles, which we're going to see are neutrons in a minute, have a mass of about 1 atomic mass unit. So this whole thing would be 4 atomic mass units, roughly, because it contains 4 little particles. Later on, those units were defined so that proton mass is going to be about, what, 1.00727 atomic mass units. So this U stands for atomic mass units. If you only want, a couple of significant figures, you can say the mass of a proton is about 1 atomic mass unit. These other particles are electrically neutral. They're called neutrons. They have a charge of 0. And they have got a mass that is almost the same, but not quite, as a proton. Their mass is 1.00866 U. So the total mass of this alpha particle, or this helium nucleus, same thing, is going to be about 4 atomic mass units. Now, the other piece of the atom, if this is a helium atom we're drawing here, would be the little electrons, which I'll draw as little purple things. And they're moving in the empty space around the nucleus somehow. Rutherford thought that they were orbiting it like planets orbit the sun, but we now know that isn't the case. These electrons have a charge of -1, and their mass is much, much smaller than the mass of a proton or a neutron. It's 0.00055 U. Now, you do not have to remember these numbers here. I'm only showing them to you for one reason. I want to show you that these two are almost one. They weigh a little bit different. A neutron is just a little tiny bit heavier than a proton. And then this one is much, much smaller than either of the other two. So if you wanted the mass of a helium atom, you could approximate it pretty well just from the proton and neutron weight. In other words, almost all the mass comes from the protons and the neutrons, which are always located inside the nucleus. The electrons are roaming around outside the nucleus. The nucleus contains almost all of the mass that you've got. Now here's a helium atom. And it turns out that you can tell one element from another, not by the mass of the atom like Dalton thought, but by how many protons it's got. Here is a hydrogen atom. It's got a proton here and an electron to balance it off. So the electron is moving around here somehow in the empty space outside the nucleus, which is a single proton. This has one proton, helium has two. If you take a look at the periodic table, you will see that there is always a number in the periodic table. Let's see, this is the one. That is on top of the element or maybe up in the corner. You'll see a little block like this in the periodic table for hydrogen. You'll see a little block like this for helium with a 2. The number of protons is a unique identifier for which atom you've got, and that has a name. It's called the atomic number. It's the number of protons. That are in the nucleus. Now what about the number of neutrons? That can vary from atom to atom. The number of protons and neutrons together is something called the mass number. It's the number of protons and neutrons. So for helium here, that we have over here, your mass number is equal to 4. It's a count of how many protons and neutrons you've got in the nucleus. Your atomic number is 2 because there are 2 protons. The number of neutrons is going to be the mass number minus the atomic number. So it'll be 4 minus 2. It's 2. So there are these 3 numbers now that we can write down. The mass number, the atomic number, and the number of neutrons that something has. This thing has no neutrons. Its mass number will be 1, and its atomic number is 1.